Okay, so let's have a look at increasing and decreasing functions. Now in particular I'm going to have a look at this cubic function, and I'm going to have a look at individual parts of it that are increasing and decreasing. So let me just mark in some points here first of all that are going to be of interest to us. So let's have a look at this point here, which is A. Let's call this one here B. There's a point here, I'm just going to call it C. Call it C on the x-axis here. This point here is D, and this one here E. Now let's have a look at some tangents to the curve between A and B. So if we take, let's say we'll draw one here. So there's one tangent. You can see that that has a positive slope, sloping to the right here, so it's a positive slope. And it's quite steep, so it have a reasonably high slope. So if I draw another one then just further up along the curve, let's say here, you can see that that also has a positive slope, but less than the first one. And then finally when we go to B here, the local maximum, the tangent will be horizontal, so it would have a slope of 0. So between A and B, we have positive slopes of tangents, but the slopes themselves are decreasing. So the fact that the slopes of the tangents are positive means that the graph or the function between A and B is increasing. So if we were to continue on from B, let's go down from B down to D here. Well, we'll initially go to C anyway and see what happens there. So let me do that in a slightly different color. So if I was to draw a tangent here, you can see that this tangent here is now negative. So from A to B, the tangent slopes were getting smaller and smaller and smaller until we got to 0. They're still getting smaller, but they're now negative. They do have value now other than 0, but they are getting smaller and they are negative. If we were to continue on, draw another one, let's see, we'll do this one here. You can see that that's also negative, and it has a smaller value than the first one I drew here, this one here. These two have both negative slopes. The second one here has a smaller slope than this one here on the number line. If you imagine, it's further left on the number line than the slope of this one here. So if we were to go down here to C then, draw another one, just down close to C anyway, we would get something like this, and then as we go past C, we would get another one like this, and then finally at D. So at D here, M is equal to 0. So what's actually happened here from B? Well, at B the slope was 0. The slopes continue to get smaller and smaller. They're negative. At C, the tangents switched from being above the graph to being below the graph here. And that point there, point C, is called a point of inflection. That's called the point of inflection. So that's this point here. So that's where the tangents have switched over from being above the graph here to being below the graph down here. Also what happens here is that the tangents from A up to B and down to C the slopes of those tangents have been decreasing. Once the tangents switch over from being above the graph to being below the graph, once they pass this point of inflection, the slopes start to increase. They're still negative down to D, but they're starting to increase now. The slopes are starting to increase. And then once we got to D, then we're back at 0 again. And once we actually pass D, what happens is the slopes start to become positive. So you can see here we end up with positive slopes, and the slopes get bigger and bigger the further up along here we go. So we have a few different sections here. So from A to B, we have an increasing function, or an increasing part of this function. because the slopes of the tangents are positive. Once we pass B, all of these slopes, all these tangents down to D have negative slopes. So from B down to D, the function is decreasing. And then we're down to 0 here, 0 slope down at D. Once we pass D, then we're into positive slopes again. So from D onwards, the function is increasing. Okay, so let's just draw another graph where we just plot, or attempt to plot some of these slopes. So if we draw another x-axis along here, and we'll leave the y-axis over here out of the way. So this is our y-axis here, and this is our x-axis here. Now, if we take, we're going to take corresponding points at A here is going to be here, if you like. This is going to be our A. And B here is where our slope was 0, so this is going to be where B is. C is where our point of inflection was, so I'm just going to mark that here. D is here, this is where we had another 0 slope. We had our local minimum here, so we had 0 slope. So that's going to be about here. And E is out here, we won't worry about that one for the moment. Okay, so what did we notice then? From A to B, we noticed that we had positive slopes. So we had positive slopes up along here, but the slopes were getting smaller and smaller. The values of the slopes were getting smaller and smaller until we got down to 0. So if we were to plot those actual slope values, we initially started, let's say, at A here where we had a fairly high slope, and as we went down towards B, the slopes got smaller and smaller and smaller, and when we got to B, we ended up with 0 slope. So remember, on the y-axis here, this is our slope value, if you like, the slope of these tangents up here. So what happened was as we plot all these points, we ended up down here at 0. We're now at this point here, B. At the point of inflection, we started to increase the values of our slopes, but we were still negative. So from B to D, we're going to be down below the x-axis here. We're going to be down here below the x-axis because all our slopes are going to have negative y values down here. So what happens here is we end up coming around like this and then coming back up here to where D is, our local minimum here. And from D onwards, we see that our slopes are now positive. So we're now above the x-axis on this graph. So this graph here is f of x, and this turns out here to be f prime x, or the first derivative of this function here. So remember, first derivatives will give you the slope function, the slope of any tangent at any point x on your original function. So you'll notice here again that we have positive slopes here, positive values here above the x-axis because all of these slopes up here are positive. Once we went past B, we have negative slopes all the way down to D, so we're now below the x-axis down here. And then after D, we have positive values for our slopes up here. So we're now above the x-axis up here. All of these represent positive values for our slopes of our tangents up here. Now the vertex of this particular one here, I don't have it drawn particularly well, but this point C here will give you the point where the slopes, remember I said up here that the slopes are still negative, and they are negative all the way around here because we're below the x-axis here. All of these tangents have negative slopes, but the slopes are decreasing down as far as C. Once we pass C, the slope values are actually starting to increase. They're still negative, but they're starting to increase. So we see an increase in the curve here. We have a decrease here, we have an increase here, and then we get the positive slopes up along here. Okay, so how do we write all of this? Now, I'm going to have a look at two different ways of looking at increasing and decreasing functions. One is simply where the function is increasing and where it's decreasing, and secondly, where it's strictly increasing and strictly decreasing. So let me just write this out. Now we would say first of all that the function f is increasing. It's increasing here. It's increasing from A to B. Okay, and the way we would write that is like this: A, B, with these square brackets on either side. That means you include A and you include B. Or you could write that the x values between and including A and B in this interval here. The function f is strictly increasing. It's strictly increasing between A and B, but now you put this curved bracket here by the B here, you don't include the B. So in other words, it would be x would be greater than or equal to A, and then it would be less than B. So it doesn't include the part, this part here, where you've got a zero slope tangent here. So that's the difference between a function increasing and a function strictly increasing. So we can go on then just to say the function is decreasing between B and, what did I call this up here? We have, it's decreasing from B down to D. B down to D. So you would include the B, you would include the D, because it's decreasing. And you can say then the function is strictly decreasing from B to D, but you don't want the points where the slope is 0, so you don't include B and D for strictly decreasing parts of the function. And then finally we can say the function is increasing. So again, you can see here the function is going to be increasing from D onwards. So x is going to be greater than or equal to D. So we're going to say here x is just greater than or equal to D. Or if you want to talk about strictly increasing, so you would say the function is strictly increasing for x greater than D. Okay, so just finally then, just to talk about the first derivative, you can define increasing and decreasing in terms of the first derivative of the function. So you can say that if f prime of x is negative for all x on an interval, so if the slopes are negative, I should say less than 0 here, if the slopes are negative for all x's on a particular interval on the x-axis, then f is strictly decreasing. And also, if f prime x is less than or equal to 0 for all x on an interval, then f is decreasing on that interval. And similarly, if f prime x here, if f prime x was greater than 0 for all x on a particular interval, then f would be strictly increasing. And similarly, if f prime x was greater than or equal to 0 for all x on that interval, then f would be increasing on that interval. So that's really it for increasing and decreasing functions. I mean, generally, your definition here would be that if b were greater than a, then you would expect f of b to be greater than f of a for an increasing part of the function. And if b were greater than a and f of b was less than f of a, then the function would be decreasing.